Hey there, this is Math 6, Unit 5, Lesson 3, adding and subtracting decimals with few non-zero digits. Okay, so we're adding and subtracting. Here we go. The first one says, do the zeros matter? Evaluate mentally. 1.009 plus 0.391. Okay, so just doing some mental math here. I can see that I'm looking at, first of all, this 9 is in the thousandths place, 110, tens, hundreds, thousandths, and I get a 1 there, which means I'm going to have to do some bundling or some regrouping, right? That 9 and that 1 are going to become a 10, which means I'm end up with a 0 in my thousandths place. Thousandths, hundreds, tenths, decimal, and here's the whole number there. So that becomes the 1 I'm carrying, which then pops over here to this 9, which that becomes another 10, and it carries over to 3, which becomes a 4, and then I have nothing else besides the 1 there, so I have 1.4. So yeah, I'm doing some computation, but what I'm seeing is I'm just showing, it's talking out loud what I'm doing in my head. I can see that I'm having to kind of regroup along the way. I regroup twice, and that's why those zeros end up going away. Decide, now at this point here I have 1.400. The question is, do these zeros even matter? That's the question. So, I mean, talk to your neighbor. What do you think? Do those zeros even matter here? Is there a difference between 1.4 and 1.400? Is there any difference between those? Okay, so think of it this way. I could add some more zeros. Am I changing anything? I have 1 and 4 tenths. I have 1 and 4 tenths. Okay, let's add some more zeros. Now I have 1 and 4 tenths. So the zeros don't really do anything, do they? That's just the end of the road there. If I had another number here, they absolutely would make a difference. But right now, there's nothing. So decide if each equation is true or false. All right. So here's 34.56 with a bunch of zeros and 34.56. So we have zeros after the 6, which don't mean anything. So this number is the same as that. I would say that's going to be true. Here we have 25 and 25.0. Again, the zeros to the right don't mean anything, so we can ignore them for the most part and say that's true. Now in this case, there's a 0 in the middle of a number, between the 4 and the 5, which is not there. If it's in the middle between regular numbers, that does make a big difference. So this one would be a false statement. Those are not equal to each other. So zeros to the right, not a big deal. We can ignore them. But once you put them in another number around it like that, gotta pay attention. Calculating sums. Andre and Jada drew base 10 diagrams to represent 7 thousandths and plus 4 thousandths. Andre drew 11 small rectangles. Jada drew only 2 figures, a square and a small rectangle. If both students represented the sum correctly, what value does each small rectangle represent? What value does each square represent? Okay, so here we have 7 thousandths and 4 thousandths. Now computationally, that becomes 0.007 plus 0.004. And we can see already 7 plus 4 is going to be 11. So we're going to have to do some regrouping there. So we have 1 there and 0 and there. So what Andre's done is Andre said, let's do 1, 2, 3, 4, 5, 6, 7, and we add 4 more, 1, 2, 3, 4. And we're okay, that makes sense. What Jada's done is Jada said, well, of all this here, you actually have 10 of those thousandths, which can be bundled up into one of the hundredth squares. So she's just done a little extra work to bundle that there. This square is the same as this bundled up one right up there. So that means that the little rectangle represents 0.001 and the square represents 0.01. So draw or describe a diagram that could represent the sum of 8 thousandths and 7 tenths. So we could have 7 squares, or little squares you should say, so 4, 5, 6, 7, and then 8 of the smaller rectangles like so for our thousandths. Something like that would work out well. If we wanted to actually add that up, we would have 0.008 plus 0.07. Put a space holder there, and what do you have? 0.078. Oops, something like that. Alright, number 2. Here are two calculations of 0.2 or 2/10 plus 5/100, which is correct, and explain why. So here we have 0.2, 5/100. We have our decimals lined up, so that looks good, that looks good. Over here, our decimals are not lined up. If the decimals are not lined up, I cannot do it. So this one is the best one. We have 5, 2, and 0. That's going to be the correct solution because the place values are all lined up, the decimals stacked up like that. That's going to be the way you want to do it. Okay. So let's compute some sums, and if we get stuck, you can draw base 10 diagrams to help you out, but hopefully we're going to be okay at this point, but if not, no problem at all. So we see everything lined up, so I could put a 0 there, doesn't matter, I don't need to, but if it helps you see it better, there it is. And again, we're just lining up stuff, right? So if 0 plus 5 is 5, 1 plus 0 is 1, 1 plus 0 is 1, and a decimal there, and a 0 there. Would I solve it like this horizontally? Nope, I'd rewrite it. So we have 0.01, and I'm going to add a space holder 0 there just to help me see what's going on. 9 plus 0 is 9, 0 plus 1 is 1, 2 plus 0 is 2, decimal comes right down, and 0 is right there. And then we have 10.2, or I can write it here as 10.2 plus 1.1456. Make sure I line things up. I can put some space holders there. Not a big deal. 6, 5 plus 0 is 5, 4 plus 0 is 4, 2 plus 1 is 3. There's my decimals, all nice and stacked up there. 1 plus 1 is 1, and 1 plus nothing is 1. So 11.3456. Would have been nice if that was a 12, huh? Just to have some 1, 2, 3, 4, 5, 6. But we'll leave it like that. Okay. Number 3.3 says, to represent 0.4 minus 0.03, or 4/10 minus 3/100, Diego and Noah drew different diagrams. Each triangle represented 1/10, each square 1/100th. And here we go. Diego started by drawing 4 rectangles to represent 4/10. Got it? So 1, 2, 3, 4. He then replaced one rectangle with 10 squares, and then crossed out 3 squares to represent subtraction of 3/100, leaving 3 rectangles, 7 squares. Okay, cool. Does that make sense? He's taking one of these bundles, he's doing this, and he's unbundling it, he's turning into that, and then subtracting. He couldn't do that first, he had to unbundle it first. Noah started by drawing 4 rectangles to represent 4. He then crossed out 3 rectangles to represent subtraction, leaving 1 rectangle. Do you agree with either one? Well, what Noah is doing is Noah is taking 4/10, right, which is this one, 1, 2, 3, 4, 4/10, and he's subtracting 1, 2, 3/10. That's what he's doing. What Diego's doing is Diego's doing 4/10 or 40 and subtracting the 0.03. There's a big difference between subtracting 3/100 and subtracting 3/10. Okay, it's just not the same thing. The problem asks you to do what Diego's doing, which is 4 minus, or 0.4 minus, or 4/10 minus 3/100. His is the right way to do it, and we would agree with Diego. Diego's doing it the right way. Let's look at the next one. It says to represent 4/10 minus 0.03, same thing. Elena drew another diagram. So Elena has another way of doing it? Great. She started by drawing 4 rectangles for the tenths. Then she replaced all 4 rectangles with 40 squares. Oh my goodness. So she unbundled each one of these into 40 squares. That's a lot of squares. Way to go. And then crossed out 3. 1, 2, 3. Leaving her with 37 squares. That's true, right? 5, 10, 15, 20, 25, 30, 35, 36, 37 squares. 37 squares. Now those 37 squares are 37/100ths, so put a decimal point right there. And do we agree with her? We would agree that that is going to be just fine. Okay. the key thing on this is that when I talked to kids before, whatever that last digit is, whatever place value that's in, that becomes the name of the whole thing. This becomes 37 hundredths. So wherever that last digit is, that last number, not a zero, that is the name you give it. Okay? Alright, so let's move down to some more examples here, some practice ones. So find the difference and explain or show your reasoning. It's important to line these things up, right? So 0.3 minus 0.05 looks like that when we line it up vertically. I'm going to add a 0 there so I can see that 0 cannot take away from 5. You can't do 10, 0 minus 5. So I have to borrow, which means unbundling that. So it becomes 2 and a 10. 10 minus 5 is 5, 2 minus 0 is 2, and there's my decimal, and I'm okay. For C, I have 1.03 minus 0.06. 3 minus 6, I can't do it. Can I go to the neighbor? Nope. The neighbor has to go to his neighbor. So we borrow from here, it becomes a 0, and that becomes a 10. Now the 3 can borrow, so that 10 becomes a 9 in order for that to become a 13. So I had to borrow twice to get that broken down. Okay. 13 minus 6 is 7, and 9 minus 0 is 9. Decimal comes down, and 0 minus 0 is 0. For B, we have 2.1 minus 0.4. 1 minus 4, I can't do that, so I borrow here and put that there. 11 minus 4 is 7, keep the decimal, and 1 minus 0 is 1. And then finally over here we have 0.02 minus 0.007. Notice when I line that up that I need to add another 0 there just to make sure it works. I'm going to borrow or unbundle, put that there. 10 minus 7 is 3. 1 minus 0 is 1. I got a 0. I have a decimal and a 0. So 0.013, or in this case here, 13 thousandths, because that's a thousandths place. And that's our idea on that one right there. Okay, so just as a summary, I'm going to again skip the Are You Ready for More? So base 10 diagrams can help us understand subtraction as well as addition. We can do that by unbundling things like we did in today's lesson. So that helps us out quite a bit. It's also really important that when you do that, to make sure if you end up doing vertical calculations, that when you do vertical calculations, make sure things line up the correct way. That's one of the key things to keep in mind as we do this here. Alright, I'm going to pause there so you can work on your homework, and we'll come back together in just a minute to check it out and see how you did. Alright, Math 6, Unit 5, Lesson 3, homework, adding and subtracting decimals with few non-zero digits. Alright, so here's a base 10 diagram represents 1 and 13 hundredths. Use the diagram to find 1 and 13 hundredths minus 0.46 or 46 hundredths here. Alright, so we could do it with a vertical calculation, or we could use a diagram. It says use the diagram. So first of all, I have 0.46, so I need to be able to take away 4/10 and 6 of the hundredths. I don't have 6, I only have 3, right? I only have 3 of those, I only have 1 of those, and I have 1 of these guys here. So I have to do some unbundling. First of all, I'm going to take this unbundle, take this stick here, and we're going to turn it into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we turn this and unbundle it into 10. Now, can I take away 6 of the hundredths? I sure can. So 1, 2, 3, 4, 5, 6. So now I have that many hundredths left, which is 1, 2, 3, 4, 5, 6, 7. 7 hundredths. Now I need to still take away 4/10. I have no tenths. So this 1 needs to become 10 of these, right? So I could think of it this way. I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I have 10 of them. I want to get rid of 4. So 1, 2, 3, 4. Those 4 all go away. Now I have how many tenths? I have 1, 2, 3, 4, 5, 6 left. 0.6. I don't have any whole numbers left, so I have 0.67 is what I'm left with. Again, stacking it vertically, we can see how that works out. I don't have enough of the 100, so I had to borrow and unbundle. 13 minus 6 was 7, so we have our 7 there. I couldn't do 0 minus 4, so I had to borrow here. That became 10 minus 4, which was 6. And that became my 6 there, and it kept the decimal, and I was out of whole numbers, so I left it just like that. Okay, number 2. Compute the following sums. Here we go. So 0.027 and 0.004. 7 plus 4 is 11, carry the 1. 2 plus 1 is 3, and 0 and decimal, and we're set. Over here, line things up, 0.1, 0.1, and I can add some space holders there, no problem. 3 plus 0 is 3, 0 plus 0 is 0, 2 plus 1 is 3, decimal is in this good spot, and 0 right there. And then finally 1.2 plus 0.145. Again, I could put some zeros there, so we have 5, 4, 2 plus 1 is 3, decimal stays there, and 1 plus 0 is 1. Alright, a student said we cannot subtract 1.97 from 20 because 1.97 has 2 decimal digits and 20 has none. Do you agree or disagree? We would say that we hopefully at this point would say disagree. That's like saying I have $20 but I can't afford something that costs me $1.97 because I don't have any coins. I think you can make some change. Why is that? Well, we can make 20 into 20.00 and go ahead and subtract 1.97 from that. That can be done. I need to borrow a whole lot or rebundle, right? Unbundle, this becomes 1, which makes that 10, but I have to get that all over there. So this has to be reduced, or we have to borrow there to go to there. We borrow here, that becomes 9, and that becomes 10. Now we can make the change. So 10 minus 7 is 3, 9 minus 9 is 0, 9 minus 1 is 8, and 1 minus nothing is 1. So it can be done. Just have to borrow a whole lot. Number 4. Decide which calculation shows the correct way to find 3/10 minus 6 thousandths. Alright, so it's important to have the decimals lined up. That's looking good. There's 3/10, and that's 6 thousandths. So this is looking pretty good here. 6, 0, 3 looks good. Here the decimals are not lined up, so we'd say no for that one. This one looks good so far. These decimals are not lined up, so we'd say no to that one. And this one, we have 0.3, 0, 0. Okay, everything's lined up here. So this is good. So that looks good so far. Now I circled 2, didn't I? Well, that's not going to work out because look, they're different. So what happened? Why is 1 okay and 1 not okay? Well, let's come back over here and put our placeholder zeros in. What is 0 minus 6? Oh, you can't do that, can you? You have to borrow, don't you? So let's see over here. 0 minus 6, they didn't get 6. What'd they do? They borrowed this to make it a 2, which makes this a 10. They borrowed that to make that a 9, and makes that a 10. 10 minus 6 is 4, 9 minus 0 is 9, 2 minus 0 is 2. D is the best answer, and so that's good. So while this one had good vertical alignment, it didn't actually do the math right. Okay, good one. Number 5. Complete the calculations so that each shows the correct difference. So let's turn the page and look at those ones here. Alright, here they are. 6 minus 4 is 2, 2 minus 1 is 1, 4 minus nothing is 4, 1 minus nothing is 1. 0 minus 5, we have to borrow there, so that becomes a 5 and a 10. 10 minus 5 is 5. We can't do 5 minus 7, so we have to borrow from here. That becomes a 7 and a 15. 15 minus 7 is 8. 7 minus 6 is 1, and we have 3 right there. 6 minus 8, I can't do that, so I borrow from here, so it becomes 1 less. This becomes 16 minus 8 is 8. 6 minus 1 is 5. 1 minus 2, I can't do it, so I borrow from here. 11 minus 2 is 9. 3 minus nothing is 3, and 2 minus nothing is 2. Alright, the school store sells pencils for 30 cents each, hats for $14.50 each, and binders for $3.20 each. Elena would like to buy 3 pencils, a hat, and 2 binders. She estimated her cost to be less than $20. Do you agree with her estimate? Let's see. 3 pencils at that is about 90 cents, right? That's about $1. 2 hats for that, let's just say it's about $15 a piece. That's going to be about $30. And, oh, not 2 hats, 1 hat, sorry. So 1 hat is about $14. And then 2 binders is going to be $6. So we can see our problem is that this is about $21, which is greater than the $20 estimate she has. Now again, we're just estimating. This is not quite $1, it's actually less, but that one's definitely more than 14, so definitely going to be more than $20. Okay? How many pencils could she buy with $5? That's our first question. Well, for this one, if it's 30 cents a pencil, if we're estimating here, let's think about this. 30 cents a pencil times how many is going to get me up to about 5 there. Well, we know that she can do 3 pencils, and 3 pencils times 30 cents is 90 cents. That's about $1, right? So we know she can go to $5, so if we multiply 3 times 5, we would say she could probably do about 15 pencils and be okay. Okay, could you do more? Probably, but again, we're just estimating. Okay, rectangular prism measures 7.5 centimeters by 12 centimeters by 15.5 centimeters. Calculate the number of cubes with a ½ centimeter that fit in this prism. Okay, it's a great question. Remember this before. If we had a cube that was only a half of a centimeter, and we want to turn that into a cube that's a full centimeter, we would add another one here to make a full. But to make it a total cube, I'd have to have another one there. I'd have to add a backside to it here, a backside to it here, and that becomes the base. And then I have to give it basically 2 layers to make it equal to a whole one, right? And so it's not a great picture, but if this one cube in the front right here, this one cube here, is that half by half by half centimeters, then it means it takes 8 of those to make a cube that is actually a 1 centimeter by 1 centimeter cube. Okay, so I'm going to need 8 of these for every 1 square centimeter is what we're saying. So if I take the volume is going to be found by multiplying all those together. So the volume is found by doing 7.5 times 12 times 15.5. Now these are all centimeters, right? So this becomes 2 times 7 is 14 plus 1 is 15 over 2 times 12 over 1. And this becomes 2 times 15 is 30 plus 1 is 31 over 2. So what I did is I said, well, let's do, there's 2 here, and how many 2's are in 12? We'd say 6. We had 2 here. How many 2's are in 6? 3. So 15 times 3 is 45. And 45 times 31 is actually equal to a number I didn't know. I had to use a calculator. 1395. So the volume of the whole thing, which is actually the next question, what's the volume? The volume is 1,395 centimeters cubed. But how many of these ½ centimeter things fit inside of there? For every one, there are going to be 8. So if you multiply 1395 times 8, that tells you how many of these would fit, which is 11,160 would actually fit there. So I actually solved part B in order to solve part A. Is there a different way of doing it? Probably, but that's the way I did it there. All right. And our last one here says a car is at a constant speed, a car travels 75 miles in 60 minutes. How far does it travel in 18 minutes? So let's take a look because they have a table here. We know that in 60 minutes it goes 75 miles. So to go from 60 to 6, we are dividing by what? We're dividing by 10. So 75 divided by 10 is 7.5. Okay. To go from 6 to 18, that's multiplying by 3. So 7.5 times 3 is 15, carry the 1, 21, 22. We have 1 behind the decimal. So we get 22.5 is how far you can go in 18 minutes. All right, that's it for today in today's lesson. Have a great day, and we'll see you next time.